Okay, so to properly explain what I've done here, I've built a artificial intelligence which uses genetic algorithms to build these walker things, and their goal is to get to the other side of the screen. It's got a time limit, and you can see it resets. So what it does is every time it loads, it's got to build these things and then kind of let them go. And what these things are is you'll see that there's points there. Each point has a different mass. The greener it is, the lighter it is. And there's ones down here which are dark, but you can see basically all of them over here are actually quite green. So the intelligence has decided a heavy point is actually useless to it. It doesn't want a heavy point. So it's using these lighter points. All the heavy ones are stuck down here, not really doing anything. And then the lines are kind of muscles. They're elastic, the elastic wants to be a certain length, and it'll try and spring to that length. And so it's pushing on the points and all the other muscles are pushing on it as well. So it kind of shakes around a bit. These are quite stable, these walkers. They're not bobbing around too much. Now the muscles, about 30% of them can develop a mutation that will cause them to change their desired length, and so they'll try and spring to that length instead. And it's just a zigzag triangular curve. It's not a sine wave or anything. Their desired length, the change in the oscillation there. And as they walk across, you can see they change. There's red ones and black ones. So the redder it is, the weaker its elasticity, or the weaker its influence on the weighted node. So a heavy one has a great influence on a very light node. A black line has a very, very big influence on a light node. A red line has a very small influence on a heavy node. So you can see there's a really strong muscle going up the back of these walkers. There. The black one is quite thick. In fact, I'm pretty sure it's put two muscles there. It has. So there's two muscles on the back there, two of the strongest muscles on the back. So it's decided that needs to be a rock solid back there. It's essentially created a spine. And now the red ones are a lot weaker. There's probably the weakest ones. It's hard to see what color red they are. And then it's got a tiny little black one down the middle as well. And so I suspect that's the one that's changing length. So I think it's evolved only one muscle that changes length. Yeah, that's the one that's changing length, is the middle one there. And the rest of them, I guess, just keep it balanced. The intelligence gets a reward for how high the points are as well that get across. So it's actually distance moved multiplied by the height. And you can see at the top here, that produces some pretty big numbers. I'll focus that. So 0 is the ID of the walker, the current best one. And these are some pretty big numbers right here of its fitness or its success level. A leap, a generation, every time it restarts, that's called a generation up the top. A leap is a situation where a generation that was at least better than the previous one. So one thing I've changed to the classic genetic algorithm process is the best performer gets a free pass into the next generation. That wasn't always the case. It was likely with normal genetic algorithms, but it's not guaranteed. And so an exact clone of the best performer comes into the next generation, and that's to prevent the evolution ever going backwards or ever decreasing in its quality. So these leaps are when number 0 is the first one added, which is the best one from the previous generation. The leap occurs when someone other than the clone is the best one. So that's how these walkers work. It's incredible to see it's all come together. And it's actually, I didn't expect it to build something that walked. I thought it would build something that shuffles along, or like a triangle with one leg or something like that. One leg hanging down the middle that sort of pushes off at an angle. Because I've seen other people's GA produce those sort of triangles. But this one takes steps. It walks. Very excited.